things tech, check out the website at sautech.edu. And remember, we're home of the Rockets. We're 89.5. We're KCAC Camden. Hello, everyone. Welcome to Rocket Launcher Live. It's a weekly program heard each and every Wednesday at 12 noon right here at Rocket Radio, KCAC. Rocket Launcher Live is a program discussing all things tech. We have faculty members, we have students, and we have members of the community. And it's all live right here at 89.5. You can also stream us live at sautradio.com. And, of course, on our Facebook page at Southern Arkansas University Tech. Now, sit back and enjoy Rocket Launcher Live.
Good afternoon, Rocket Nation. It is kind of a chilly day out there in the Rocket Nation. Where did our sunshine go, Troy?
It will be here in 2 days.
Here in 2 days. Well, yeah. I cannot wait.
Summer starts kind of, sort of, next week. That's when the temperatures start getting back into the 80s.
Well, that'll be great because we've had softball action all weekend, and the weather held off, and we had 2 victories against my old school at Carl Albert. It was great to see some friends from Carl Albert, but it was also even better to see the Rocket Nation score 2 victories. We're getting geared up for a regional play. It starts this week. Our ladies will be in action. The number 3 seed, they'll be taking on number 6 seed South Ark. Then next Wednesday, our Rocket men will be in action. They are the number 1 seed, conference champions, SAU Tech Rockets. And they will be hosting the winner of the 4-5 seed game, which is National Park versus North Ark. So we eagerly await the winner of that game this Saturday evening. And basketball season's coming to winding down, but softball season's in the heart of its season. A lot of action going on in the Rocket Nation. So you need to check out our website and come check out a game. But today we're going to be talking about all things non-destructive testing and all the different types of non-destructive testing. But before we get to my special guest, a friend of the show, I want to remind our listening audience out there on sautradio.com, or if you're listening to us on KCAC 89.5, or if you're watching us on our Facebook page, the mission statement of SAU Tech. SAU Tech is a comprehensive community college that meets the educational, training, and cultural needs of the communities it serves. And one of those communities is our defense industry. We are in South Arkansas here in Camden, Arkansas, or as we like to say, out in the EC, out in the East Camden area of Arkansas. We are the heart of the defense industry. All things defense sits right here in this part of Arkansas, and it's a major part of our economy. It's a major part of our educational purpose, the direction of many of our programs, but just really the guide and compass for our whole community. And that's why I always say, and I gave a lecture series, a lecture about a month ago to the Eisenhower School of National Defense, and I talked about how SAU Tech, this little rural school, really stands in defense of a nation because the programs and the students that they're producing go to work in the defense industry. And we're highlighting one of those programs right now today, and that's with our lead instructor of the program, Jerimie Butler. Welcome to the show. It's glad to have you back on the show. You're no stranger to the show, but remind our listening audience a little bit about your background in non-destructive testing.
Sure. Well, thanks for having me today, Dr. Morrison. It's always good to come over and see you guys. So I've worked in the aerospace industry most of all my career. I've got 23 years experience in non-destructive testing. I'm an NAS 410 level 3 in radiographic testing and liquid penetrant testing, and also ASNT level 3 in radiographic testing. So that didn't mean a lot to a lot of people, but when somebody asked me,
it sounds pretty impressive. I'm not going to lie, that sounds pretty impressive.
Just a lot of letters, doesn't really matter. Looks good on paper, but I get asked a lot. So what do you guys do? And the simplest answer I can give is we make the invisible visible. When you've got problems, safety issues, quality concerns, NDT is the go-to. You work hand in hand with engineering to help them understand the differences in the components, what may cause failure modes. So been doing it a long time, work with a really awesome team of people, and it's been a good career.
As an instructor and as somebody that's been in the industry for 23 years, that's remarkable because you're only 25. I mean, it's just it's remarkable. But a lot of people, because I over the weekend I gave two tours of the campus, and I talked about different programs, and I talked about NDT, and I get a lot of blank faces. There's just really a lack of awareness of what NDT really is. And you mentioned a few: dye penetrant. There's the old school kind of radiography. I'm going to just use some shorter terms, and I'm going to let you go through them all. There's mag particles. Yep. There's digital X-ray. When you meet someone or prospective students that has no knowledge of NDT and they just hear the initials, what's the best way to explain it to them to create an interest in the program? Because to me, I'm truly fascinated about the program that we have and what it does and the doors it opens to students. How is the best way we can explain what they would be doing on a daily basis? You mentioned engineers, you mentioned failures, ensuring that there's no failure in operation. How can we communicate that to a student, prospective student out there?
Sure. So one of the most enjoyable things about working in NDT, and especially the aerospace industry and here in Camden, I get to work with some of the smartest people in our state, some of the smartest people in our country. We've got some amazing engineers, and NDT works hand in hand with the quality team and the engineering team. So you get to work in a diverse group, and you learn a lot. It's a continuous learning experience throughout your career, and also you get to see aspects of parts and rocket motors that not the average individual gets to see. We get to see all the internal workings, inside and out through radiographic imaging. You mentioned conventional radiography, which was like what we used to see years ago, where they would take an actual piece of X-ray film, expose it to X-rays, develop it, and then you've got a hard copy that you can review on a light box. In radiographic testing, it's migrated almost completely into a digital form of image detection, and that's something that SAU has invested in, and they've got a really amazing lab. They've got digital detector arrays, computed radiography systems, and we do discuss some film radiography in our courses. But you get in these classes, you get real world exposure to the tools that you'll use in the field, and it's pretty amazing what you've got right here in your backyard. It's an amazing training facility.
And I was visiting with the aviation program. We think about aerospace and defense, but that also includes kind of a branch into just the aviation on its own. And they were talking about mag particles and dye penetrance earlier this week. I don't know if you caught the show. I crank propped a plane. I didn't die. I was actually kind of nervous, but this is something that we're seeing increasing in other area industries outside of aerospace and defense. The rail car industry.
Absolutely.
I know I talked to owner of a rail car company about students, and I think they do some mag particles testing. Then
UT inspection, type thing, yeah.
Exactly. The lingo.
Yeah.
The aviation industry. I mean, it's a vast profession. Oil industry, welding industry, anything that's welded as far as inspections. It's just, Troy, it's truly amazing to think about how far-reaching. You hear these three letters, NDT.
Yeah.
But what it truly means when you start going through everything.
Well, you want to be able to, you hit the nail on the head. There's just about every manufacturing industry has some form of NDT. Maybe it's visual inspection, just looking and making sure components, but you want to ensure that what you're manufacturing and selling to your customer is going to perform. And you can't always fire every rocket motor to make sure it's going to do what it's supposed to. So your next best
costly.
thing. Yeah. So you got to have a method to get and understand what's going on inside these different components, different manufacturing areas, to say, hey, this is going to do what we told you it was going to do.
And of course, in our defense industry, there's nothing more important to ensure that those mechanisms work.
Absolutely right.
Because the men and women that defend our country, the greatest nation on earth, depend on what you guys are doing. The students that we're producing are doing it at such a level that continue to protect this nation. That, to me, that's kind of humbling to think about as an institution. Let's talk about some of go through some of the courses. You're our lead instructor on this. You basically have your hands on all these students as they come through for the 2 years of the program. And we can also talk some of the other courses they take in support of the NDT classes. So what do students start off with when they enter into the non-destructive testing program here at SAU Tech?
Sure. So step number one, when it comes to working in any industry, I believe safety should be your first focus, and that's our first course is radiation safety. learning to work with radiation-producing equipment, understanding the risk. That's step number one. You got to get through radiation.
You got those little
safety.
meters over there and badges over there.
Yeah, absolutely. And the first time I walk up to a student and start scanning them, they ask me, "What are you doing?" It's just always fun to play with them. But if a student is going to learn anything, the most important thing to me is making sure when they leave this facility, they understand the risk and they understand how to operate in the industry safely. So radiation safety is number one. Our second class is radiographic testing level 1, and that is just getting an individual ready to, when they go into the workforce, they know the ground level work that they're going to be performing, the methodology behind it, the reason why they do what they do. So that builds off of radiation safety and gives them some practical application. We do a lot of lab work. We practice taking good radiographic images. To sum it up, level 1, that's what you got to be able to do. You got to take good quality radiographic images. And then when you progress into radiography level 2, that's getting a little more deeper into not only taking the x-rays, but understanding the anomalies that are produced in the radiographic image, how to digest that information, how to translate that into a report. Is that a relevant indication? Is it going to cause failure in the field? Just knowing what bad looks like, what you're looking for, just in a basic overview of radiographic testing in level 2. And then, so you're also offering dye pin inspection, and that's more of a surface indication, a surface inspection, to bring things that you can't see with the human eye, to bring it visible. And pretty simple test, but man, there's a lot of theory that goes into how it works and why it works. But if you just looked at the exterior on the test, it looks like you're just applying a dye to a metallic surface, clean it off, put some developer on it, and look and see what bleeds back. But when you get to understanding how capillary action works, how all the mechanics work in this test, it gets pretty deep. And then also magnetic particle inspection. And I know a little bit about magnetic particle, but I'm sure not a subject matter expert. But the magnetic particle inspection is also another good surface inspection technique, where you're going to use iron particles suspended in a carrier or a fluid of some kind, and it's got to be done on metal parts. You got to be able to magnetize the part. So you magnetize the part, you bathe it with this solution. The iron particles will gather where there's a surface break in that component, and you look at it with a black light. The iron particles will reflect will luminesce back where you've got a flaw or a break in the material.
So I know it's that black light's in there now, Troy. I thought we were supposed to just go in there and listen to 70s music and turn the black light on, but now I know what it's for over there.
Yeah. You could do a good lint inspection on a white T-shirt.
So it's 5 classes at the heart of the program. Then it's a 2-year degree. Of course, you get your general education, then classes like blueprint and safety classes and things like that, some engineering classes. It's truly a remarkable degree to think you can complete it in 2 years and go right to work. Let's talk about that. A student comes in, are they accumulating hours that transition with them to the work through training and practice?
Absolutely. So there's guiding documents out there that employers have that an individual has to satisfy certain requirements to be qualified as a technician. And SAU's giving them that classroom training to satisfy those hours. So you're valuable. When you walk out of this program, you're valuable to an employer. You just saved them tens of thousands of dollars from taking a grassroots employee and training them up. SAU gives them all of that, and they're valuable. So what does that mean to the individual? Well, I'm a little more valuable to the company, so I can ask for a little more compensation. And that's something students want to know. How much am I going to make? But that gets you from entry level to the next step up. So
when you leave this program, are you at a level 1, level 2, and of course, how many years afterwards does someone usually work before they can move up to level 3? And I know there's always continuing education and training that student has to do. Can you kind of walk through? I graduate from SAU Tech with the NDT degree. Where am I at that point based on my training?
So when you walk in the door after this program, you've got some OJT hours you got to satisfy first, but you've met a lot of the basic qualifications to become a level 2. Does that mean you're going to walk in as a level 2? Not necessarily, but it has greatly reduced your time to get there.
Okay.
And then when it goes to a level 3 or a NDT engineer, it's a little different. So a lot of that's going to be based on the individual. That one's a hard one to answer. You get someone that's engaged with the process. they've got the competency to do. It's not unreasonable to think within a few years they could become a level 3 NDT engineer, and I can tell you, level 1s, level 2s, they're all level 3s. Every one of those classifications, they're able to live a good life and live the American dream.
Are those currently in high need right now, all 3 levels?
Absolutely. Aerojet, Lockheed, all these other surrounding companies, all of them have NDT, and all of them have a need for NDT technicians.
And that's what I think really we also want to hit today, not only informing the listening audience out there and viewing audience out there what NDT is all about, but also about the high job need. And it's available here at SAU Tech, the only program in the state of Arkansas that has an NDT program. And I want to say it's the only one within about 6 or 7 hours as far as training.
I think you're right. Yeah.
I think Tulsa and Houston might be the closest ones around.
Yeah.
And to have that here at this institution in the heart of the defense industry is just truly remarkable. Troy, where can they find more information out about this NDT program?
The website is www.sautech.edu.
I mean, this program is about 2 years old now, and you've been at the heart of it ever since. It really helped us get the room set up and all the equipment set up, and really thanks to the industries. They're the ones that donated a lot of the equipment that we have in the lab. And, of course, I think we helped through some grants purchase some testing, and that's what's fascinating. You see these suitcases, and you're like, what are these? Well, these are testing plates and stuff. Those things are a couple $grand a piece.
Yeah, man. NDT equipment and test specimens it's all expensive. NDT's expensive, but it's a necessary evil.
But it's also a program that falls under Our Futures, which is the ADHE grant that's available. And basically, if you're eligible for financial aid, your financial aid will cover cost. Anything after that, Our Futures will come in. Not housing, but for the tuition and fees and stuff, Our Futures will come in. And NDT, we're not going to lie, it's kind of like the Welding Academy of South Arkansas. It's an expensive program. You fire up those machines, it gets costly. And to get the true experts in the field, it gets costly. We know that. But we also know it's a very important career field. And so Our Futures will come in and help cover the costs for the student. And that's what's great about having a grant like that in the state of Arkansas. We were just talking about that earlier this morning in the Welding Academy and Our Futures. But this is another program, and Connie's going to like me plugging this because Connie Riley in her office will help you for all financial aid applications, processes. But you really need to, if you're interested in Our Futures, you need to NDT, you really need to check out the Our Futures grant because it will basically help you walk out with no cost for the tuition and fees for the program. Now, if you choose to live on campus, we can make that happen as well. But as far as the cost of the program, it's an excellent way to leave and go right to the workforce. Like you said, no matter if you're level 1, level 2, and you work your rear off to get to level 3, because I imagine it's a lot of work and a lot of training and a lot of classes and testing. I mean, you can make a truly great living. This is something we're proud of this program here at SAU Tech and what we're doing here. Let's talk a little bit more. What's an average? It's a night program. How many nights a week does it run?
A couple of nights a week at least.
So we do 2 nights a week. So it does run at night. So great for non-traditional students who want to get a kind of re-education or retraining. Hey, if you already work in the industry,
absolutely,
and you want a way to advance up, this would be a great program. I know our industries are great supporters of encouraging their workers if they do not have a degree or maybe some have started a degree. I've seen a lot of that in this area, especially working out of the park where they started at SAU Tech one time but never finished. Hey, we need to get you back in the fold and get you in the mix and get you completed and so forth. But this would be a great program if you're looking for a change in your current job.
Oh, absolutely. Yeah.
So let's talk about what's an average night when you walk into class for a student. What type of theory are they learning, and then when they get into the lab situation?
Okay, sure. Well, with radiation safety, one of the first things we're going to look at is what's the allowable dose limits for radiation exposure. And of course it's as low as reasonably achievable. I beat that acronym ALARA into the student's head, as low as reasonably achievable. You don't want to get any exposure. Day one, we're gonna talk about that. We're gonna understand the biological effects of radiation, how to calculate X-ray exposure, how much dose you get over time, exposure rates, that type of thing. Understand the difference between radioactive isotopes and X-ray machines, knowing the sources of radiation. And
because that's a pretty powerful machine over there in that building. So there's nothing to play with, is it?
Yeah, well, any source of radiation is nothing to play with. And I'll try to put a little fear in the students at first to respect what you're working with, and we don't take any clowning around. So that's the first thing that we're going to talk about in radiation safety. And then we progress through that. We're going to do some algebra, learn how to calculate, some formulas like the inverse square law, to understand how radiation exposure, as you increase your distance from a source, how the intensity is reduced. It's always a good thing to know when you're working. How far do you have to be away to be safe? And then with radiography, we're going to go into principles of good image quality. What does a good image look like? How do you prove it's a good image? What parameters do you have to stay within to meet the industry standard to have repeatability of good X-rays? So.
Well, I want to ask a question. Let's say we're shooting film, kind of the old school, conventional, as you said. I always say the old school radiography, but the conventional radiography, you're shooting film. Let's say this is a manufactured piece. When I'm looking at that film, what am I looking at? What are you training the students to look for when they're looking at that film and so forth?
To keep it simple, basically you're looking for different shades of gray.
Okay.
As a material becomes less dense or you've got open space, that allows more radiation to penetrate. And if you get more radiation penetrating through the part, exposing the plate, you get a stronger, darker indication on your film. Mm-hmm. So you're basically, to keep it simple, you're looking for different shades of gray. For instance, a crack in a component, if you get the orientation just right, it's going to look like a really dark, intermittent, feathered line on the radiographic image.
And it's something, if we were you and I were just looking at this piece, we're not going to see it.
Oh, no. Yeah, you're talking about internal burst or cracks within the component. Or let's say that you've got some type of foreign material that shouldn't be there. If we're working with plastics and we get a metal inclusion of some type, the image process is a little bit different on how it's going to be represented on the film. That denser material is going to block X-rays, so that's going to create a brighter indication on your film. So you're basically looking for different densities within the material that may point out that you've got a flaw in the material, or like I said, cracks, missing components. All those are going to become visible on your radiographic image.
Okay. And digital X-ray be the same, basically looking for the same thing when you're doing digital?
Well, the cool thing about digital X-rays is there's a lot of manipulation tools within that software when you produce an image. Larger dynamic range, you can invert the image to where on an X-ray film you're looking at a negative. You can invert the grayscale and view it differently. You've also got different zoom magnifications. If you really want to upset a production guy, have a small component that you're X-raying and you blow it up 400 times, he thinks you're looking under a microscope to reject his parts. So, but yeah, there's a lot of different tools encompassed in digital radiography, and I tell you, it's just really amazing. In my time in the field, how much it's changed and how much how much you can see and how much how efficient it's become and how sensitive it's become.
And I know you said you wasn't mag particle was not your main area. So mag particle, now explain to again, what is it doing? I know you explained the dye penetrating, you're putting a dye over it and coming to the surface. The mag particle, because I know in talking with rail car industries, they've mentioned mag particle testing a bunch to me. What is that? How is that working again?
So you've got a there's a couple of different ways, but we're gonna talk about where you use like the equipment that we've got over in the lab. You've got a tank with a suspended carrier fluid in it. Maybe it's mineral, maybe it's kerosene, and then there's real fine iron particles that are in that fluid. It's suspended in that fluid. So you would place a part on that workbench. You've got two conductors on each end. You induce a magnetic current through that part. It becomes magnetized. And then there's spray nozzles in the workbench that you will spray over the component, completely wet it with the carrier solution. The iron particles that are suspended in that bath, they're gonna come to where there's flaws or breaks in that material. The magnetic field's gonna pull them in there. And then when you look at iron particles under a black light, it fluoresces back. Mm-hmm. So really small cracks that if Jason and I were sitting here and we're trying to see with a magnifier, we may not see. When you put it on that mag bench, and you inspect it and you hit it with that black light, they're going to stand out like a sore thumb.
Oh, wow.
Yeah.
Troy, I mean, I'm today's been extremely...
This is impressive, man. Now, Jeremy, he comes and gets on my program on Friday at my radio station. You are picking up on some of this lingo, aren't you there, boss?
I'm going to need Jeremy to come down to the radio station on Friday. and
we
talk
need some
about
of this lingo because my folks on my ears never heard these big, long words like this before. So
we're about to bring him down sometime because today you really, I mean, we walked our students, potential students, through every aspect of it. This is, and I guess what I've been running a theme kind of here lately. Sometimes we don't realize how advanced career and technical education really is. We kind of have this image in our mind of kind of the back in the days when Troy was a whippersnapper.
Yeah, that was a long time ago. Dirt was invented then, by the way.
But man, these career and technical type fields are just amazingly impressive.
This is fascinating, is what it is. And I was sitting here just listening to it, and the way he's describing it makes sense, and you can picture it all in your mind. You're doing a great job, and of course that is a great field. And let me ask a question: this is for men or women? This is not just totally a man.
Men, women, or other.
Is this one of those fields that we hear in welding where women are so detail oriented that sometimes they really excel?
I'll tell you, there's a lot of women on my team, and they are. It's a good field for men or women, but anyone with a high attention to detail, perfect field for them. If you like looking for the missing piece of the puzzle, it's a great field to be in.
And it's so crucial. Let's touch on that again. It is so crucial to have people in this industry because you're truly, that man and woman that's in that forward area or in that battlefield is depending on you that you did your job.
Oh, absolutely.
And that's what I think is just amazing to see how this all comes together, especially for us here in Camden, Arkansas, how this little community, some people don't even know we're down here.
Yeah, I know.
That, wow, we play such a major role in how the world works and how our nation can posture itself, and stand in defense of really the world. Because this little small community here in Camden, Arkansas, and the men and women that serve at your industry and at the other defense industries in this area. Troy, I mean, I lost for words on that.
Yeah,
it's just
it's pretty fascinating. And folks don't realize it's all happening right here within a 3 or 4 mile radius of this studio right here. And a lot of stuff's going on out here in this area.
Oh, yeah.
What's cool is when we're doing a tour one day and the ground rumbles and shakes. And people are looking around. I was like, they're just testing the rocket motor.
Dude, what?
What? And I go into it and I talk to them and I talk about our different programs, NDT, our robotics program, our engineering technology. We have a new engineering technician program, Eddie Horton's mechanical maintenance program. All of these jobs are extremely valuable to this area. Supply chain management.
Absolutely.
But this NDT, I'm really proud of what you've done with this NDT program because it's really becoming, in my viewpoint, a marquee type program, a program that really separates an institution from other institutions because no one else has it.
That's right.
And that's what really impresses me about it is what all the industries that came together to do to make it happen. And y'all, folks out there watching this and listening, do not realize how much time Mr. Butler has put in to develop this program. He's really been the heart and soul of this program.
Well, SAU has had the vision. I mean, you guys, when we first started talking about this, you guys identified this as a critical need for the area, but it's a lot bigger than that. There's a high demand for NDT here, but there's a high demand for NDT nationwide, worldwide. So
we got some new equipment coming too. I know we submitted for a grant, so we're getting some new NDT equipment because Kat Beckham and Dee Waldner are going to incorporate more NDT into aviation. So I have this feeling y'all going to be all visiting with each other.
Yeah, that'd be great. Yeah.
Because we're wanting to see how we can translate this across the board more. I mean, Kat just went to Houston and did a lot of training. Just because we see how, like you said, there's other industries, I mean, I could very well see Casey in the Welding Academy, starting to do some more inspection type training and incorporate NDT in the Welding Academy. It's a lot of opportunities out there for students. And the thing is, you mentioned algebra and you mentioned all this. You're teaching all that, and you're teaching it in a manner where the student doesn't hear the word algebra and run away.
Yeah.
Because a lot of students, they hear that word, out the door. But you're able to teach engineering terminology and skill sets and algebra and mathematics skill sets without having it be so intimidating to the students.
Yeah. Well, and you got the lab set up right there, so it's not just a formula on paper. We're gonna learn what that application is, and then go put our hands on it, and not only work it on paper, but then see how it works. So it's and that's how I've always learned, and I've got a lot of good feedback from the students on that. So yeah, you're right. It's if you don't have that practical application, it becomes scary. But when you've got a lab as nice as what SAU's got, makes it so much easier on the student.
Well, Jerimie, I thank you for being here today. This has been extremely informative. I can't wait to see the feedback from those that are watching it now and watch it later. We've been averaging about 600-700 views per weekly show. So hopefully we can get more information out there about non-destructive testing. If you would like more information or would like to get in touch with our lead instructor over this, yes, he does have a day job, but he does help us out and answer questions. Troy, where can they find that information?
Thanks for asking there, Chancellor. The website is www.sautech.edu.
I have no clue who's going to be here next week. Do you have the list?
I have not. No, sir. We need to tell everybody about, don't forget, the Rocket Night.
Oh, yes, we do need to talk about Rocket Night. It's coming up April 24th. I do apologize. We have sold out of all the VIP tickets, but you can get a general table, which is $200, or you can get just a general ticket for $25 to come out and support your Rocket Nation and help our student athletes, help our scholar students. Our scholar students are going to be running a silent auction. We'll be auctioning off some football items. I know we're going to auction off an autographed Razorback helmet. So if you want more information about that, you need to contact Amber Savage, asavage@sautech.edu, or you can go to our website and click on Rocket Night to get more information.
I think you could even order these online, can't you?
You can order the tickets online. It's going to be a great night. Jerimie, I hope to see you out there on that night. Come listen to Houston Nutt. But come check us out. Our next show next week, we're going to have Miss Laura Howard talking about the School of Professional Cosmetology, and they're going under. Right now they're under construction. We're redesigning the whole laboratory for the cosmetology program, and Miss Howard has just brought in some great insight, wisdom, and knowledge to the program, and that program will be starting. The new program will be starting this summer. So Miss Laura Howard will be here next week.
Okie dokie.
So, Troy, I'll see you Friday morning.
All right.
Jerimie, I'll see you around as we continue to move this ship forward, this rocket ship forward. And I appreciate what you do for SAU Tech, and we'll see you next week.
Yeah, thanks for having me.
Thanks for listening to Rocket Launcher Live. Rocket Launcher Live is a weekly program heard right here at 89.5 KCAC.